Hello and welcome back. QA usually gets a staging environment where the application is already running. It works until it doesn't. And when it fails, QA is often the scapegoat. But how the system runs was already decided before QA ever touched it. And at that point, QA isn't testing, they're just guessing. When a test fails, do you actually know what version was running and what started fresh and what didn't? Or did it just magically work this time? If you can't answer that, you don't really know what system your test ran against. Now let's step away from the questions for a second and look at what we actually have today. From a QA perspective, this looks fine, right? The environment exists, the tools are installed, but we still haven't defined how the actual application runs. And without that, QA has no control over the next test run. And that's the problem that we're gonna fix in this episode. This is the application under test today. Right now it's only running locally on my machine. It's just a very simple e-commerce website, nothing fancy, nothing special, just for context. But this doesn't tell us what's actually running right now, so let's define that. In this case we do that in a Docker Compose file. It's simply a file where we describe what starts and how for the application that we want to test. So the first thing we define here is the version under test. In this case, it's a backend version, which makes it explicit what version of the application is actually started. So when a test runs, and especially when it fails, QA knows exactly which version it ran against. Then the next thing that we define is order. This tells us which part of the application needs to start first and which ones needs to wait. In this case, we are waiting on the database. The backend won't start until that dependency is actually up and ready. And the last thing we define here is the readiness signal. This is how the application itself tells us when it's actually ready to be used. Not just started, but ready. So now we have defined how the application runs and with which versions. That execution needs a clean place to run. This is where we circle back to the foundation we built earlier with Terraform. This is the same Terraform setup from episode 3 that created our dynamic test environment. And from there, Ansible takes over the output from Terraform to actually furnish the environment, just like we did in the previous episode. Last time we only verified the setup by starting a simple Docker hello world. This time we are going to start the actual application, the e-commerce application we defined earlier in this episode. And once this command finishes, it's up and running. The foundation is in place, now we prepare the environment by installing the necessary tool, just like we did in the previous episode. As a QA, this assertion tells me the application process is running. Now I actually want to verify that for real. So I'll take the IP from the output and I'll check whether the application is actually reachable in the browser. And this doesn't work, but that's expected. The application is running, but it's not reachable from the outside yet. That's because the application listens on a specific port and access to that port isn't allowed yet. So to make it reachable, we need one small edit in the Terraform file. And importantly, this change only updates access to that port. Everything else stays exactly the same. Good. So we apply this change to the dynamic test environment. It doesn't recreate anything, it just updates access to that port. We then open a browser. And now the URL is accessible. As you can see, the application is running, this time not locally, but on our dynamic test environment that we've built together. Now that the application is running on our test environment, the next step is obvious. We want to actually test it. Up until now, these rest assured tests that you see in front of you were pointing only to my local machine. What changed is where the application runs. So instead of hard-coding localhost, we pass the URL of our dynamic test environment via the command line. And as you see, the test passed, running against our own created dynamic test environment. So let's take a step back for a moment. What we just did wasn't about tools or commands, we just defined how the system actually runs, end to end. So this is what it means when QA controls execution. We define how the system under test runs. We can run that exact same system locally, and we can run that exact same system on a clean dynamic test environment. Same system, same execution. And because of that, we finally get results we can trust every single time. So this finally closes the loop. The environment is reproducible, the execution is defined, and test results are consistent everywhere. And that means QA finally has real control over their test environment. Not by dictating infrastructure decisions, but by testing against an environment that behaves the same every single time. QA is now in full control of the execution, and that's where trust comes from. In the next episode, we'll take this exact flow and run it automatically in a Jenkins pipeline. Thank you for watching and see you next time.